Welcome to the release webinar of the latest version of Midas Civil 2019 version 1.1. My name is Sinkyu Nam, a technical engineer of Midas IT. So today I would like to introduce some of the useful features developed in this version. So the first part will be analysis and design part for the software. So traffic load model for Turkey, moving load optimization for Australia, nonlinear elastic link for pushover analysis, H2LRFD 2016 update, and the shell design for Eurocode. And I will show you a brief demonstration of how to do this in the program. And the second part will be pre and post processing of Midas Civil, energy result graph for time history analysis, strain output for material nonlinear analysis, multilinear force deformation function for point spring support and elastic link, rail track analysis report with US unit setting, and the last one will be data interface with GTS NX. And I will show you another brief demonstration how to sort of give and take those data between Midas Civil and GTS NX. First of all, new Turkish live load model are implemented. The load model for KGM vehicle and H vehicles for Turkey are implemented now. And these vehicles are quite similar to H2, so these vehicles can be found under H2 LRFD and H2 standard code. So here are some of the examples of the live load model for the Turkey. Moving load optimization for Australian standard is now open. So you first have to define the optimization lane, which is the total width of the carriageway, excluding the margin that you specify. And the program will shift the traffic lane based on the analysis lane offset that you defined. So this function will help you to locate the critical position of the vehicle in both transverse and longitudinal direction. Moving on, next topic is nonlinear elastic link for pushover analysis. There are two ways for considering the boundary conditions for pile support. So you could either apply point spring support or elastic link on the pile structure. So previously it was not possible to take into account the elastic link for the pushover analysis. So this elastic link part was not provided in the old version. However, you could consider the nonlinear behavior of the elastic link in pushover analysis from this version. The load factor for WS load type and permanent effect for extreme event 1 load combination in H2 LRFD has now been updated. So these load factors are updated now. And the new equation for the resistance factor calculation is updated now as well. Shell design. This is one of the major updates of this version, and it is implementation of reinforcement concrete shell design as per Eurocode 2 National Annex LL. So shell design allows us to obtain 3 membrane forces, two flexural moments, twisting moment, and 2 transverse shear forces. Shell design is similar to the plate design that we have already, but it is differentiated based on the internal forces considered for the design. So shell design is inclusive of axial force or membrane force, where the program calculates based on the sandwich model. This design feature can be applied to concrete shell structure, abutment wall, wing walls, and underground structures, such as like a box culvert. In terms of work process, it follows a quite similar process to the plate design. So you first have to define the domain and subdomain. So this is the window dialog for the subdomain. And then you have to select the member type as shell, and then you need to define the rebar direction and then select the element as well. And then you can provide the rebar information from this dialog, or the program can suggest you this as well by performing the shell flexure design. Based on the information given, you can select rebar here. So rebar direction 1 or rebar direction 2, and the following can be obtained. So membrane axial force, membrane shear force, rebar stress and required reinforcement area and the ratio, and the rebar arrangement will be obtained if you select rebar direction 1 or direction 2. But if you select concrete, so these results will be obtained. So membrane axial force, membrane shear force, and principal compressive stress of concrete will be obtained. For shear checking, shear resistance and concrete resistance ratio can be obtained. So shell design. Shell design is based on two conditions, either cracked or uncracked. So if it's for uncracked, it will be quite simple and straightforward, and if it is decided to be cracked, we will then apply the sandwich model, which is described in this figure. So we will apply sandwich model, where the shell is divided into 3 layers. So specified thickness of top and bottom layer, and the inner layer in between. Top and bottom layer will mainly consider bending moment and membrane forces such as axial and moment, as well as twisting. And the shear will be taken by the inner layer, and the required rebar will be suggested based on this. So just to remind you, plate force is obtained from the analysis, and it will be decided whether the particular elements are cracked or non-cracked. So if it is uncracked, it will go for maximum compressive stress. And if it is cracked, sandwich model will be applied, and this will be used to define the rebar arrangement, and the strength of reinforcement and concrete will be obtained through this procedure. Then before moving on to pre and post processing, I will quickly show you how to do this in Midas Civil. So I have prepared this completed model file of this box curved structure. So first of all, you have to define the domain of the plate element. So here I have defined the domain of the side, this side. So once you define the domain, you have to define the subdomain of this structure. So like what we did for the plate design, we will have to define the subdomain of the plate element. So here you can see that I have selected this side element, plate element, and then I have defined the member type as shell, and then you can also set the rebar direction using local UCS option or reference axis option as what you have done for the plate design as well. So I have defined the subdomain for the side and both back and front of the wing wall on the left hand side. Then you can close this, and then you can go to design, and you can set the design criteria for the rebar. Here you can choose the rebar sizes and then the spacing as well. And also you can specify the concrete face to the center of the rebar, which is the cover for both direction 1 and direction 2. Then you can also specify the initial thickness for both top and bottom layer of the sandwich model. So you can define this proportion, or you can obtain this through the optimal design through the iteration process with these parameters. So I'll just quickly close this. And also you can obtain this. You can obtain the design result automatically using the design feature. So shell flexure design. Here you will have to select either load cases or load combination, and then you can obtain the design result for both or top or bottom option. And also you can select the rebar for both direction 1 and direction 2. So if you select rebar option, so all these design result are obtainable. So membrane axial force, membrane shear force, rebar stress, required area for the reinforcement, the ratio, and rebar arrangement. All of these results are obtainable. And if you select concrete, membrane axial force, membrane shear force, principal compressive stress, and the ratio will be obtainable. So if I click rebar here, and then if I click apply, you'll be able to obtain the design result for whatever the domain and subdomain that you have specified as a shell element. And then all of these design results will be obtainable in this graphical format with the legend on the right hand side. And this result is also obtainable in terms of text format. So if I click this option for design result text output, you can see that for the side 1, the subdomain side 1, you will be able to check the shell flexural maximum result, the information for the parameters, and you can see whether the section is correct or not. So you can see whether the sandwich model should be used or not, and the membrane forces will be calculated, and all these design results will be calculated based on the membrane forces that you obtain through this procedure. And also these results are also obtainable in terms of table format. So design result table, and then you'll be able to obtain all of design results in terms of table format. So once you design this shell element, you can also check the shell element with the specified rebar setting. So if I go to shell rebar for checking, so you can define the information for both top and bottom for direction 1 and direction 2. So you'll be able to define the rebar size and the spacing, and then this will be applied to the shell element that you have. Okay, so quickly close this, and if you go to shell flexure checking, you'll be able to see pretty much similar interface, and then you'll be able to sort of check all these design results based on the rebar settings that you have input in this option. So if I click apply, you'll be able to see the design result based on whatever the rebar settings that you have input in this function. And same for the text format as well. And this will be also obtainable in table result as well. So now let's go back to the presentation. So coming back onto the pre and post processing part, it is now possible to review the separate energy result for time history analysis. So for isolator and vibration control devices in the nonlinear time history analysis. As you can see, dissipated inelastic energy and both damping energy result. So these results can be checked in terms of different proportion in the latest version. But as you can see in the previous version, it is very difficult to see which proportion is taken up by dissipated inelastic energy and also damping energy. These results can be obtainable in terms of value type or percentile format as a type of display. text report can be outputted as well. And this function is also applicable for both element and nonlinear link such as dampers as well. Plastic strain result of plate and solid element can now be reviewed. So previously it was difficult to see the damage result of each element after analyzing the concrete damage model. New post-processing function has been implemented in the latest version, and now the damage result of each element can be checked in terms of both graphical and table format as well. So these are the examples of numerical format, numerical result of table format. Moving on, multilinear point spring support was defined by specifying 6 points only in the previous version. But now you can create a function where unlimited number of data can be defined for much more accurate consideration of multilinear forces, just like in this dialog box. Rail track analysis report was only available in metric system, but now it can be generated for US unit system as well as SI unit system. In order to consider the soil structure interaction, you must have data from geotechnical engineers normally. So in Midas, we have a software called Midas GTS NX where 2D or 3D analysis of geotechnical problem can be performed. So from this version, either reaction or the displacement nodal result can be exported onto Midas GTS NX once the analysis is performed from civil. So this nodal load can now be imported onto GTS NX where it is applied as either nodal load or specified displacement. So basically geotechnical analysis is then performed in Midas GTS NX, and the nodal load result can be exported as a displacement, reaction, or force/displacement form. So displacement result can be used to apply as specified displacement for settlement, and reaction result can be interpreted to find out the vertical stiffness, and force and displacement result can be used to create multilinear support to consider the soil structure interaction when you export the nodal result from Midas GTS NX back on Midas Civil. And then you'll be able to do this multiple times in terms of iteration process, and then you'll be able to consider the soil structure interaction very effectively using this. So finally, I will briefly show you how to do this in Midas Civil and Midas GTS NX. So now let's quickly open Midas Civil. So here I have the completed model file for the precast composite girder bridge structure. So you can see that the pier cap is going here, and then pier, and then the pile cap, and then pile structure going under the ground. And as you can see, I have created these point spring supports in the pile structure already using the pile spring function in the boundary conditions under the integral bridge feature. So you first need to perform the analysis to export all those nodal results. So first perform the analysis and then go to export nodal result for GTS NX. So you can specify, you can select specific nodes, or you can just select all for the nodal result for the boundary conditions. If you have construction stage, you can specify certain stages and select load cases or combinations, and you can export the result type in terms of either reaction or displacement, and result component in all these directions. So I will just quickly select all for the reaction and click OK. So if you do this, you can see that all those nodal reaction result is exported in terms of text format. Then you also have to export this structure in terms of MXT file format in order to import this in Midas GTS-NX. So now let's open Midas GTS-NX. So you first have to import the MXT file for the bridge structure. Click open, and you can see that all those structure has been imported onto Midas GTS-NX. Then you will have to create the ground structure. Let's quickly create the ground structure underneath the bridge structure. And click preview to check whether all those information has been inputted correctly. So click preview. You can see that this is right below the ground condition. So click OK. Now you need to generate the mesh on this soil structure. So before generating the soil structure, you first need to create the nodal points and the edges along the pile structure. So this is because when you create the mesh, when you generate the mesh, you want to generate the mesh based on these edges, so the mesh doesn't intersect this pile structure. So let's go to the point, create geometry point, select 3D, and let's select convert node and select all the structure. Okay, let's go to points again and 3D option and convert node. This will convert all those nodal information into this. And click OK. So now we have created all these nodal points here in terms of geometry. And let's select polyline, select 3D, and click this. All those nodal point. So now we have created all this so you can see that we have created all this line along the pile structure, and let's translate this into all the other pile structure as well, and select all the edges that you just created using this filter, and then select 2 points vector, and let's copy this twice along X direction. Click apply, and let's select edge filter again and click all these edges and select 2 points vector again and copy distance from here to here is 4.3, and let's copy this 3 times. Okay, so now we have created all these edges along the pile structure. Now let's generate the mesh along this solid structure, full solid structure. So right click, generate mesh. Here you can see that this option, interior edges, then you can see that 120 edges are selected, and click OK, and let's click OK for generation of the mesh. And as you can see, the mesh is generated correctly, so we can use this mesh for the analysis or the geotechnical analysis. Let's quickly create the boundary conditions here using the auto option. Select object and click OK. And now, before performing the analysis, I want to sort of import the nodal result from Midas Civil. So go to File and Import nodal result, and let's select this and click Open. So let's look at this. So you can see that this nodal result is imported onto GTS NX. So all this reaction result is now imported onto my GTS NX. So now you need to create the analysis case. Click Add. So let's create test analysis case with nonlinear static. Go to analysis control and go to nonlinear option. Let's set the number of increment to 5 and every increment in order to create the multilinear spring support. Click OK, click OK. Now let's quickly perform the nonlinear static analysis of this structure with the ground condition. Okay, so the analysis is performing now. So once you finish performing the analysis, you will then export all those nodal results at these nodal points along the power structure, and then you will then import all those nodal results onto Midas Civil, and it will automatically convert all these results onto point spring support for the power structures. So let's just wait for a few seconds to finish the analysis. Okay. So analysis is nearly finished. Okay. Okay, so analysis now seems to be completed. Okay. Good. So once you finish performing the analysis, as I mentioned, you can export this nodal result in terms of MXT file format. So if I open export nodal result, you can select all option or specific nodes, and here I will select load set, and then if you go to output data, you can see which analysis set to be exported, and also for the result type, if I select the load set, I can select force/displacement. And for the result component, I will just quickly select all, and let's click OK. And let's just write this down as revision 1. Let's just write it as revision 2. So let's go back to Midas Civil. So I will quickly import this nodal result onto Midas Civil, and the program will automatically create multilinear point spring support along the power structure. So in order to do that, we first have to delete the power spring support that we have already, because this is not going to overwrite onto the this is not going to update this point spring support in Midas. It will just simply add new point spring support. So let me go to export, import, and nodal result, and let's select revision 2 and click open. So as you can see, all those point spring support is imported onto Midas Sybil through the geotechnical analysis from Midas GTS NX. So thank you for joining our release webinar today. So if you have any questions in terms of technical questions, you can contact us to this technical support platform. And if you have any sort of feedback, you can send us any feedbacks through this platform as well. Thank you very much.